we need to be able to relate these two to each other. So I'm going to do this. I'm going to rewrite this with sine and cos. And what ends up happening is I end up with an equation that looks like this. All over cos x equals 0. Well, if it's equal to 0, equaling to 0 is really nice, because if it's equal to 0, I just need to say that that equals 0. As long as I observe my restriction, that cos x is not equal to 0. I'm not dividing by 0. This is my restriction. Okay, so as long as I don't get solutions for x where I get at pi over 2 or 3 pi over 2 where cosine is equal to 0, as long as I don't have that overlap with the solutions up here, then I'm okay. So what I'm going to do then is I'm just going to solve the numerator of this function. So I'm going to go 2 sine x minus 1 equals 0. So sine x equals 1/2. Okay, well, where's sine x equal to 1/2? Well, quadrant 1 and 2, x is going to be equal to pi over 6. X is equal to 5 pi over 6. And the period, in this case, since there's no horizontal compression or expansion, the period is 2 pi. And those solutions do not overlap with my restriction of cos x not equaling to 0. So cos x equaling to 0 would have been here and here. Okay, so the last one here, we need to actually come up with a trig equation. Okay, so when I draw these angles in here, I've got my pi over 6 and pi over 7 angles. They kind of are in this orientation, pi over 3 and pi over 4, that orientation. If you look at these, well, how can I need to be able to relate some angles here to each other. Otherwise, I have to have a solution for this, independent solutions for all those solutions. And they happen to go on forever as well. But what I can do is I can group these two solutions, okay, at pi over 3 and 4 pi over 3. Because they are really just separated by 180 degrees. And there's some symmetry. And we can actually use tan to do this. But those are not related to the green ones here. Okay, although the symmetry is the same, it's 180 degree symmetry, the red and the green seem independent of each other. I don't really want to mix them together. Well, if that's the case, I know how to separate solutions because I know that solutions can be separated by factors that are equal to 0. Because this solution is independent of this solution here. So then I just need to come up with equations to solve this pair in here, and I need an equation to solve for this pair, which I'm going to put in there. Well, since the symmetry is tan, or is opposite, I'm going to use a tan symmetry, and I'm just going to say this. Tan theta is equal to the slope. Well, that slope I know is 1 over root 3. So, I better write this here. Tan theta is equal to 1 over root 3. Well, if I want to put that into a solution, I know that it's going to be the back over the front. Okay, so root 3 is my front. And there's the equation, there's a factor that generates that equation, which deals with that slope right there. Then I'll do the same thing here. This is pi over 3. That slope is going to be root 3 over 1. Okay, so I know that tan theta, because again it's the symmetry is tan, is going to be root 3 over 1. Well, I want to write that as an equation. It's going to be tan theta minus root 3. Okay, that's my factor that gives me those solutions. So there it is. There's my equation that gives me those roots. Okay, this equation then will give me roots at all those points. Okay, and I've figured that out based on, first of all, grouping them with the symmetry, relating it to tan because of the symmetry, and then separating out the two separate types of equations here by putting them to two different factors.